The second objective in topic 4 of solving radical equations is to actually solve them, solving radical equations, but also checking for valid versus extraneous solutions. All right. So two pieces of this: you're going to solve the equation for the variable, but then check to see if the solutions you find are valid or what's called extraneous. So I'm going to talk about the term extraneous to begin with. So everything we do in this lesson builds on a foundational concept for solving, which we've applied several times in the previous units, meaning the square root versus squaring something, all right? So to solve a radical equation, and I know that these are radical equations because of the radical sign or the square root sign, or a cube root, whatever root it is, we essentially square both sides of the equation to undo the radical. So if it is a square root, then you square both sides. If it's a cube root, then you would cube both sides or raise to the power of 3. Mainly the opposite of what's happening to cancel it out. And so I'm going to do this in example A, and then I'm going to do example B as well, but example B is going to show you what can happen sometimes when you reach an extraneous solution. All right? So in order to get rid of this radical, I square both sides because I know squaring and taking the square root are inverses, they cancel each other out. And whatever I do to one side, I have to do to the other. So now this square and this square root cancel each other out. I have x equals 9. And I'm done. It's a very simple equation, but I've solved the equation. Now over here, example B, it's the same process. I square it, and I square it. So now I have x equals 9 as well, all right? So I have x equals 9 for both things, but the second piece of this objective is to check to see if this solution is valid, meaning does it make sense in the original equation. The original equation, square root of x equals 3, I'm going to put 9 back in there. The square root of 9 instead of x equals 3, and the square root of 9 is indeed 3, and 3 equals 3. So that solution, x equals 9, for this example, the square root of x equals 3, works. It works perfectly. Now, over here, though, I'm going to do this above here. If I do the square root of x equals negative 3, and I put 9 in for the square root of x, square root of 9 equals negative 3. In this case, the square root of 9 is 3, which does not equal negative 3. All right? So notice here that we solved correctly, but when we plug the solution back in, the positive 9, the equation is not balanced or true. 3 does not equal negative 3. So this doesn't work. And this is going to happen with radical equations. We will get an extraneous solutions. In this context, it means that the solution is mathematically correct. Again, when I solved this example, I did it mathematically correct, and 9 is correct. But it's not relevant or useful as far as the original question is concerned. So I want to know what x has to equal here to solve this, and it does equal 9, but it's not relevant to the original equation. So I have to state that it doesn't work. The x equals 9 doesn't work for this example. So just be aware of that. Anytime you have a solution that you've stumbled upon, there will be times when it doesn't work because we're taking the square root or cube root, whatever it might be, and it doesn't work in the example. It doesn't equal itself out. So you have to be aware of that moving forward when solving these types. And so the first thing I would do, and I've listed the steps out right here, it's a similar process as anything. In this case, the radical will typically be trapped under, the variable will typically be trapped underneath a radical, all right? When it's that, I have to isolate the radical. That is step 1. Making sure that one radical term is alone on one side of the equation, all right? If there's multiple radicals, I have to move one so that they balance each other out. But in this case, I just have to get the radical and what exists underneath the radical by itself, all right? Step 1 will look different depending on what the equation is offering you, but that's always your goal. Get it by itself, all right? Then after that, you apply the power rule, raise both sides of the equation to a power that is the same as the index or the root of the radical. Solve the resulting equation. To step 3, if it still contains a radical, repeat steps 1 and 2, And then your final step is check all proposed solutions in the original equation to make sure one of them isn't extraneous. And again, extraneous here is when you put it back into the equation and you get something 3 does not equal -3. It doesn't equal its original equation. All right. So I'm going to do the first step. And again, I put in blue, don't forget to state the domain. So actually, I'm going to do that first because that's review. Domain, I set what's underneath, I'll draw an arrow. What's underneath the radical, 2x minus 1, greater to or equal to 0. All right, then I solve for x. I add 1, I have 2x equals 1, divide by 2, divide by 2. So x, is greater than or equal to 1/2. So this is my domain. And I need to make note of that for this equation. That should be reviewed by now. We've practiced that skill. So x has to be greater than or equal to 1/2. That is my domain. Now, to actually solve for the x that exists here, the first step is to isolate the radical for solving these things. When I do that, I notice that there's two other things that are in existence on the left side of the equation with my radical. My radical is this entire chunk. If it helps, you can draw a little door to close it off. And so I know that the only thing that exists underneath the radical is 2x minus 1. So this 3 that's being multiplied to the radical and this minus 9 that's being subtracted from the radical are not invited to the party on the left-hand side. I got to kick them out. All right? So I kick out the furthest thing. And technically this 9 is the furthest thing away because that 3 is right up next to it. All right? It's super close. I got to do that second. All right? So in order to kick the 9 out, I have to add 9 to both sides. And I'm going to rewrite everything. So this is my first step. It's going to be a multi-step piece. But now I have 3 times the radical of 2x minus 1 equals -3 plus 9 is +6. Now I'm ready to kick out that 3. And I know that the 3 is multiplying with the radical because it's just next to it. It's just right up next to it. There's no sign in between it. Whenever that's the case, it means multiplication. 3 times the radical of 2x minus 1. So in this case, I have to divide that whole left side by 3, and I have to divide this side by 3. That cancels out the 3 over there, and I'm left with, finally, just the radical of 2x minus 1. And that equals 6 divided by 3 is 2. So I'm done with step 1. I've isolated my radical. And again, that will look differently depending on the problem that's given to you, but I have isolated it, meaning I've got it by itself on the left-hand side. Now I move on to step 2. I raise it to the power, or apply the power rule. Raise both sides of the equation to a power that is the same as the index or root of the radical. If you remember, this is a square root. That should be, or it's technically a 2 right there, so I have to raise this to the power of 2. You cancel out the root of 2 and the power of 2. Whatever I do to one side, I have to do to the other. So this 2 goes away, and that radical goes away. So now I've freed up what's underneath the radical. It was stuck inside. I've canceled out the radical. It's free. I have 2x minus 1 equals 2 squared is 4. And now it's just a linear equation. I know I've done this work right up until now because I have no more radical signs. They're gone. Cancel them out. And I had to get them by themselves in order to even cancel them out. All right? Now I just solve for x like I would any linear equation. I have to read it's 2 times x minus 1, but I have to kick out the 1 first because it's furthest away from the x. It's being subtracted, so I add it to both sides. So now I have 2x, cancels out here, equals 4 plus 1 is 5. I divide by 2 because 2 is being multiplied. Divide by 2. So x equals 5/2. That is my solution. So now I get to apply the fourth rule. Check all proposed solutions in the original equation. All right, this is going to be some, not necessarily ugly math, but I am working with a fraction. So it's 3 times the radical of 2x. So 3 times and this is my fourth step, sorry. So I need to see this as well. Your fourth step is put it back into the equation. 3 times the radical of 2, now times my x of 5 divided by 2, or 5 halves, minus 1, still underneath the radical, and then minus 9 equals negative 3. I'm sorry, not negative 3, equals, yeah, negative 3. All right, now I have to see if this actually works and that it does equal what I say it equals. So I'm going to clean up what's underneath the radical first. 2 times 5 halves, there's a 2 on top and a 2 on bottom. I'm just left with 5 in there. So now I have 3 radical of 5 minus 1 minus 9 equals negative 3. 5 minus 1, so 3 times the radical of 4 minus 9 equals negative 3. Square root of 4 is 2, so now I have 3 times 2. This became a 2 here, and it's still multiplication. Minus 9 equals negative 3. And then finally, 2 times 2 is 4. 4 minus 9, let's see if that equals negative 3. In this case, 4 minus 9 is negative 5. Negative 5 does not equal negative 3. So my solution that I found, this is extraneous. So I need to label this, meaning it's not relevant to my original equation. It is a solution, it's mathematically correct, but it doesn't work with the original equation. All right. So I've done an example. I want you to do the same thing I just did, all 4 steps with the you-do problem. So the first thing you're going to do is state the domain that I did here. Then you're going to do steps 1 through 4. All right, isolate the radical, apply the power rule, solve the remaining equation, check to see if your solution is correct. So please pause your video and try that. At this point, you should have paused your video and tried the you-do problem on your own. The first thing I did was state the domain. I set what was underneath the radical, just the x plus 1, greater or equal to 0. I found that x has to be greater or equal to negative 1 in order for this to work. Then I went about solving the equation. The first step is to isolate the radical. So hopefully your work looks like mine. I just rewrote the equation to begin with up here. And then I subtracted 2 from each side because 2 is being added to the radical. Now in step 2 you can see that it is by itself. All right? And negative 4 minus 2 is a negative 6. When it's by itself, I can apply the power rule, and so I square both sides to cancel out the radical and the power. That frees it up to be in step 3, and negative 6 squared is positive 36. All right? Then I just solve the remaining. I subtract 1, so I get x equals 35. That's my solution. At this point, I need to check that. So I put 35 back into the original equation. Instead of x plus 1, instead of x plus 1 plus 2 equals negative 4, I put 35 plus 1 underneath the radical. So that's what I replaced x with 35. 35 plus 1 is 36. 36, the square root of 36 is 6. So on the left-hand side, I have 6 plus 2 equals negative 4. 6 plus 2 is 8. 8 does not equal negative 4. So I have found a solution, x equals 35, but in this case, I need to label that it's extraneous, so it is not relevant to this original equation. If you did not get that for your work, please raise your hand and I will come check it.